Hi children and viewers. In this video I am going to explain about the series combination of capacitors. Dear students, this is the one of the most important topic for examination point of view in intermediate examinations IPE. At the same time, the same topic is very important for competitive exams also. So that's why you have to watch the video very carefully and don't skip the video while you are watching. So here in this video you are going to learn what is the equivalent capacitance of series combination of capacitors. So here first thing is, what is mean by series combination of capacitors? How we can call the combination is series combination? In that, how the charge can be arranged. So here now, first already I explained you what's that. Generally we can say that the circuit symbol of a capacitor is like this. Clear? This is the circuit symbol of capacitors. So now generally this should be taken as generally called as first plate and second plate. This one is the first plate of the capacitor and this one is the second plate of the capacitor. And now in between these two some dielectric is there. Clear? So here how we can say that series combination of capacitors? How we can say that the combination is in series combination? For that, simply we have n number of capacitors. First they should be arranged in series like this. So watch carefully children. Here we are taken 1, 2, 3 and so on. Clear? So we are taken n number of capacitors. Now this is the first capacitor of capacitance C1 and this is the second capacitor of capacitance C2 and this is the C3 and this is finally Cn. Clear? First capacitor of capacitance C1, second capacitor of capacitance C2 and third one is its capacitance is C3 and so on. We have final capacitor is its capacitance is Cn. So after that, here they should be connected like this. So what I am telling, this is the first one, second plate, first plate, second plate, first plate, second plate and first plate and second plate. Clear? First capacitor, second capacitor, third capacitor and fourth capacitor. The connection should be like this. Here this is what second plate of the first capacitor, second plate of the first capacitor. Here that should be given to the first plate of the second capacitor. Again what you have, second plate of the second capacitor is joined to the first plate of the third capacitor. Clear? And second plate of the third one is given to the first one of the fourth capacitor and so on like this. Finally what we have, first plate of the first capacitor, second plate of the last capacitor. Here the number n, if you can take 4 capacitors then n value is 4. If you can take 5 capacitors, n value is 5 like that. So generally here in this one we are saying that n number of capacitors. N number of capacitors means nothing but here n1 is the last one. Clear? In this combination what you are having now, first capacitor first plate, second capacitors second plate, they only remaining all are joined together. Now across these two one battery should be given. So this is the battery of potential V or battery of potential V. Now this one is called here series combination of capacitors. Series combination of capacitors, it is the general definition for that. Clear? What's that? First, all the capacitors should be arranged in a row. Clear? they are in horizontal row. After that, here second plate of the first capacitor is joined to the first plate of the second capacitor, and second plate of the capacitor is joined to the first plate of third capacitor, and second plate of the third capacitor is joined to the first plate of fourth capacitor, and so on. After joining all those, what you have to say, we are having first plate of the first capacitor and second plate of the last capacitor. These two are given to the opposite terminals of battery. Opposite terminals of battery. Opposite terminals of battery. So that should be called generally series combination of capacitors. Simply all the plates are arranged in series order, and one plate of the capacitor is given to the another plate. So and so on. Finally, what you have, first plate of the first capacitor and second plate of the last capacitor. These two are given to the opposite terminals of battery. Now this is what we call series combination of capacitors. So now here we want to derive the equivalent capacitance or resultant capacitance when different type of capacitors are connected to the one particular combination. So for example, here now we have taken three capacitors. First capacitor of capacitance C1, and second capacitor of capacitance C2, and third capacitor of capacitance C3. Clear? We have taken now three capacitors. So if C1, C2, C3, if these three capacitors are arranged in series, then how we can find the equivalent capacitance of that series combination? So let's discuss here. So what I told you, according to series combination, what you have to say? This is the first plate, second plate, first plate, second plate, again first plate, second plate. As for definition, what you have to say, second plate of the first capacitor is joined to the first plate of the second capacitor, and again second plate of the second capacitor is joined to the first plate of third capacitor. C1 means first capacitor, and C2 is second capacitor, and C3 is third capacitor. Now second plate of the first capacitor is joined to the first plate of second capacitor, second plate of the second capacitor is given to the first plate of third capacitor. Finally, what you have here, what you have to observe, the first one is first one of the first capacitor and second plate of the third capacitor. So these two are given to the opposite terminals of battery. Opposite terminals of battery. Clear? So in this case, you have to observe. So this is the capacitance of capacitance C1. And this is C2. And this is the capacitance of C3. Clear? In this case, you have to observe the distribution of charge. Distribution of charge. So here, this is the positive charge. Clear, children? This is the positive charge. So that means here, positive charge is supplied to the first plate of this capacitor. Clear? So now this is what you have to say, plus Q. Clear, children? Children, you have to observe very carefully here now. This is the plus Q charge. So due to the induction process, here already we discussed in the first video of this chapter, working of a capacitor. I explained there how the capacitors works. So up to now you didn't see that one, you must watch it. I will mention its link in my description of this video. Clear? And now this is the plus Q some positive charge on the first plate of the capacitor. Due to that, some charge is induced. Due to that, negative charge of same amount is induced on the second plate of the capacitor in inner side. What you have to say? In inner side. And along with the minus q charge, some plus q charge also induced. Clear? Children, to understand the diagram very clearly, I will draw very in big size. Here, this is the first one, second one, and third one. They are in now series. You have to observe how the charge distribution should be takes place. So what I am telling here, this is the positive charge. So this positive terminal will send the positive charge to this one. Clear? Due to this plus q charge is available on the first plate of the first capacitor. Due to that, some negative charge. Here, what you observe? The positive charge will be sent like this. Plus q. Clear? And after that, what you observe here? Due to the plus q charge, minus q is induced on the second plate of the first capacitor, and along with that, some plus q charge is induced on the outer surface of the second plate. Don't confuse, children. Due to this plus q charge on the first plate, simply here the negative charge is induced on the second plate inside, inner surface, and same the positive charge will be induced on the outer surface of the second plate. This plus q charge will be sent to the first plate of the second capacitor. So again same thing. Here plus q is induces. Then obviously here again same process. This plus q is there on the first plate of the second capacitor. Again, due to that, what you have to say? Minus q charge is induced in the inner surface of the second plate of capacitor, and along with that, some plus q charge is induced. Due to this plus q charge, minus q is induced on the second plate of the second capacitor on inner side, on inner surface, and again same, the plus q charge is induced on the outer surface of the second capacitor. Again same process. This plus q charge is again supplied to this one. So plus q, and again what you have to say, this is the minus q and this is plus q. Clear? So again this is plus q. This plus q should be attracted by this negative terminal of the battery. So in this way the positive charge will be supplies. Clear? So children, actually no need of this much of depth for this series combination of capacitors, but you have to understand that how the charge can be distributed on the plates of a capacitor. That's why I am going into the very depth level or basic level here now. So here just observe, children. Now we are taking three capacitors. They are contained in series combination as shown in the figure. Here we want to know about how the charge can be distributed. Here the first plate of the first capacitor is joined to the positive of the battery, and second plate of the last capacitor is joined to the negative terminal of the battery. In this case, you have to observe that the positive charge is supplied to the first plate of the first capacitor. Due to that, some minus q charge is induced on the second plate inside. Similarly, the plus q charge also induced on the outer surface of the second plate of the first capacitor. The charge which is developed on the outer surface thus should be shifted towards the first plate of the second capacitor. Again same process, here plus q is there, due to that minus q and plus q charges are induced. Again this plus q charge is applied to the first plate of the third capacitor, and again due to this plus q, minus q and plus q charges are induced. And again the plus q charges which is on the outer surface of the second plate of the last capacitor, that should be attacked by the negative terminal. So the positive charge will move from higher potential to the lower potential. If you want to explain the same thing here, in this case this is the negative charge, negative terminal, that's why it releases the electron. This electron should be moved like this, opposite to the positive one. It's very simple. The positive charge is moving from higher potential to the lower potential. If you want to show the negative charges movement in the same diagram, you have to show like this. This is the electron, again going like this. So this is the distribution of charges. Distribution of charges on the capacitors. So to understand very clearly, I explained like this. So if you want to get very simple manner, now you have to follow this one. So children, so I am simply for average and below average students to understand very simply here. This is the C1 first capacitor, and this is the second capacitor of capacitance C2, and this is the third capacitor. To remember very easily, you have to practice the diagram should be like this. So this is the C1, capacitor of C1, and this is the capacitor of capacitance C2, and this is the capacitor of capacitance C3. And here the series combination will be like this. Here second plate of the first capacitor is joined to the first plate of the second capacitor, and second plate of the second capacitor is joined to the first plate of third capacitor. Finally what you have, first plate of the first capacitor and second plate of the second capacitor. These are given should be like this. So this is the positive charge or positive terminal, and this is the negative terminal. After that you have to mention this one on positive, on first place what you have plus q charge, and on this one what you have minus q charge. Again plus q and minus q, again plus q and minus q. So to remember simply, in series combination on first plates what you have positive charges, on second plates what you have negative charges. Here the amount of charge on the positive plate, first plate and second plate are equal. Clear? That's why the charge available on the every capacitor should be same. Clear? And in series combination, you have to remember that two important points. That is, here the charge is moving in only one direction. That is the first thing here. The charge is moving in only one direction, we have to consider. And next thing is, charge on every capacitor is same. Charge on every capacitor is same. This is the second key point. And third key point is potential difference across every capacitor. Is different. Potential difference across every capacitor is different. And we can say that V is equals to V1 plus V2 plus V3. This is the important thing here. V is equals to V1 plus V2 plus V3. Children, in series combination, you must remember these 3 points. In series combination, the charge is moving in only one direction. That's the first thing. And second thing is what? Charges on every capacitor is same. Clear? And third one is the potential is varies from capacitor to the capacitor, and what you have condition? V is equals to V1 plus V2 plus V3. Here what is V1? V1 is the potential across the first capacitor, and V2 is the potential difference between two plates of second capacitor, and V3 is the potential difference across the two plates of third capacitor. Simply I am showing here, this is V1 and this is the V2. What's that? Potential difference between these two plates, that is what? V2. And again the potential difference between these two plates is what? V3. V1, V2, V3. And what is V? V is the effective potential, the potential of the battery. What we are supplying the potential, that potential should be taken as the equivalent potential or resultant potential. Clear? The potential what we are supplying to the capacitors, that is what we call effective potential. The effective potential is nothing but sum of the individual potential across the capacitors. The potential across the all individual capacitors should be taken as sum of the individual potential should be equals to the equivalent potential what we are supplying to the entire combination. Clear? The algebraic sum of individual potentials across the capacitors is equals to the equivalent potential supplied by the battery. So children, you have to remember these 3 points in series combination. So here now I am going for equivalent capacitance value. Equivalent capacitance value. So children, here I am writing now C is equals to Q by V. What is that? C is equals to Q by V. What is C here, and what is Q, and what is V? So this is the equation number 1 I am taking. Here C is the resultant capacitance or equivalent capacitance or net capacitance. After adding the all, we are taken capacitors of capacitance C1, C2, C3. How they are arranged? They are arranged in series. When they are arranged in series, then their combination should be taken as here series combination. For that combination, one resultant value of capacitance is there. That should be here C. And C is the equivalent capacitance, and Q is the net amount of charge what we supplied, and V is the equivalent potential. Equivalent potential. Now by using that, I am writing here. Similarly, by using that for first capacitor. First capacitor, what do I say? Here C1 is equals to Q1 by V1. And similarly for second capacitor, what do you write? C2 is equals to Q2 by V2. And here for third capacitor, what do you write? C3 is equals to Q3 by V3. Clear? The effective capacitance should be written as C is equals to Q by V. By using that, we are writing the values for C1, C2, C3 like this. C1 is equals to Q1 by V1, and C2 is equals to Q2 by V2, and C3 is equals to Q3 by V3. So what I told you in series combination, so here we have one combination is there. In series combination, we have conditions. What is that? V is equals to V1 plus V2 plus V3. This is equation number 2 now. V is equals to V1 plus V2 plus V3. Now you have to substitute the V1, V2 values. Here C1 is equals to what, right? Q1 by V1. From that I am writing V1 is equals to C1 is equals to Q1 by V1. Then V1 is equals to what, right? Q1 by C1. Clear? And CD is equals to Q2 by V2. From that what, right? V2 is equals to Q2 by C2. And similarly here V3 is equals to Q3 by C3. So this is the value of V1, this is the value of V2, and this is the value of V3. Very simple. From these equations only we are writing the expressions for V1, V2 and V3. V1 is equals to what? Q1 by C1, and V2 is equals to what? Q2 by C2, and V3 is equals to what? Q3 by C3. Then here substitute. V is equals to, here already from this one what write? From equation number 1 also what you have write? V is equals to what, right? Q by C. V is equals to Q by C. C is equals to Q by V and V is equals to Q by C. Substitute here. V, instead of V what you have write? Q by C. Q by C is equals to, Q by C is equals to V1 is what? Q1 by C1. Q1 by C1. Again Q2 by C2. Again Q3 by C3. Simply, already we have values are there. V, V1, V2, V3 values are there. So we are substituting all these values in equation number 2. Then what you get? Q by C is equals to Q1 by C1 plus Q2 by C2 plus Q3 by C3. So what I told you, clear? So children, to get the space I am erasing this one. I am simply drawing like this here. This is the potential of V. Same diagram, no modifications. So then I am writing here for space. Instead of V what to write? Q by C. Q by C is equals to Q1 by C1 plus Q2 by C2 plus Q3 by C3. Clear children? So already what you know, second point is what is? In series combination, the charge supplied to the every capacitor is same. Clear? The charge available on the every capacitor is same. That's why here what you have to write? Q1 is equals to Q2 and Q2 is equals to Q3 and Q3 is equals to Q. So here simply we are writing Q by C. Q by C is equals to Q by C 1 plus Q by C2 plus Q by C3. Children, how we are writing? In series combination, Q1 is equals to Q2 is equals to Q3 is equals to Q. That is the condition here. Then here what you get? Q cancel. Then what you get? 1 by C is equals to 1 by C1 plus 1 by C2 plus 1 by C3. So this is the expression for equivalent capacitance. Equivalent capacitance or resultant capacitance of the series combination of capacitors. Series combination of capacitors. Simply what you write? Here 1 by C. What I told you, C is the equivalent capacitance. Then 1 by C is what? Reciprocal. Reciprocal of equivalent capacitance. Reciprocal of equivalent capacitance is equals to the sum of reciprocals of individual capacitances of the individual capacitors. That is what we call series combination of capacitors. 1 by C. 1 by C is the reciprocal of equivalent capacitance. That should be equals to the sum of reciprocals of individual capacitance of individual capacitors. Individual capacitors. Children, this is the expression for equivalent capacitance in series combination. Okay children, let's see again once here. Very important topic. Just see here. We are having 3 capacitors. They are arranged in series order as shown in figure. Here capacitance is C1 here for first capacitor. For second capacitor Q2 and third capacitor Q3, C3. C1, C2, C3. Clear children? You have to observe in this case the potential difference across the 2 plates of a first capacitor is V1 and across the 2 plates of the second capacitor is V2 and here V3. In this diagram we are showing simply Q plus Q minus Q plus Q minus Q plus Q and minus Q. That means what? The charge on every capacitor is same. Clear? So that's why here in series combination the charge on every capacitor is same. That will move in only one direction. And next thing is what? The potential difference at every capacitor varies from one to the another. The potential difference is varies from one capacitor to the another capacitor, and what your condition is there, V is equals to V1 plus V2 plus V3. Clear? So this is the condition here, V is equals to V1 plus V2 plus V3. Now according to the capacitance definition, C is equals to Q by V. Q is the net amount of charge what we supply to the capacitors, and V is the applied potential that should be taken as equivalent potential, and C is what? Equivalent capacitance. So from the we are writing C is equals to Q by V. From that what to write? V is equals to Q by C. So according to that, we are writing V1 is equals to Q1 by C1, and V2 is equals to Q2 by C2, and V3 is equals to Q3 by C3. Now we are substituting the V value, V1 value, V2 value, V3 value in equation number 2. Then here, after substituting that, what we get? Q by C is equals to Q1 by C1 plus Q2 by C2 plus Q3 by C3. What I told you, in series combination, all charges are same on different capacitors. So that's why here we are writing instead of Q1 we can write Q, instead of Q2 what you write Q, instead of Q3 what you write Q. Then what you get? 1 by C is equals to 1 by C1 plus 1 by C2 plus 1 by C3. This is the expression for equivalent capacitance when we have series combination. In this series combination, how we are defining that? The reciprocal of equivalent capacitance is nothing but sum of the reciprocals of individual capacitances. Children, in this case you have to observe the equivalent capacitance. The equivalent capacitance is smaller than the highest value of combination of capacitors. Clear? In series combination, what we are getting, the capacitance or equivalent capacitance, that values must be less than the least value of capacitance of a capacitor in that combination. Clear? For example, here we are taking 2, 4 and 5 microfarad capacitors. What is the equivalent capacitance now? 1 by C is equals to 1 by 2 plus 1 by 4 plus 1 by 5. Here the value what we are getting, that should be less than the least value of combination. In this combination 2, 4, 5, in that least value is what? 2. The value what we are getting, that should be less than the 2. That is the series combination. So in this case, here in this series combination, to maintain the series combination, we have to supply the more potential. Because what we say, C is equals to Q by V. We are adding the less C value. Then what means V value is more. And here, children, you have to remember some points here. If n number of capacitors which have equal value, that means what? 1 by C is equals to 1 by C1 plus 1 by C2 plus and so on 1 by C3 or Cn. If you can take, all are having same value, C1, C2 and C3 and so on is equals to Cn. For example, here I am taking CS. CS is the equivalent capacitance. So now C1, C2, C3 all are having same values. I am writing now here 1 by CS is nothing but 1 by C plus 1 by C plus and so on 1 by C. How many times? N times. That means what? 1 by CS is equals to, we can write simply N by C. So this is the very simple logic in problems. You have to observe this one. 1 by CS is equals to what? N by C. This is another key point. Clear? When we have number of capacitors and they have equal capacitance value, then you can easily find out the capacitance value like this. 1 by CS is equals to N by C, or CS is equals to C by N. And after that, in problems, for example, here C1, C2, two capacitors are there, they are in series. Then how we get it? Simply 1 by C is equals to 1 by C1 plus 1 by C2. So simply I am writing here 1 by C is equals to, here C1 by C2 is the LCM. Then what to write? C2 plus C1. Then what do you get? C is equals to C1 C2 by C1 plus C2. So like that. So this is the effective capacitance value. C is equals to C1 C2 by C1 plus C2. Simply here 1 by C is equals to 1 by 2 plus 1 by 4. How we can get? Simply here 8. Then what do you get? 4 plus 2. So 1 by C is equals to 6 by 8. Then what do you get? C is equals to what? 8 by 6. 8 by 6 means what? 4 by 3. 4 by 3 means what? 4 by 3. 3 ones are 3. Again 1. So what do you get? 0. So 9, 1. So it means what? 1.3 here. What do you get? 1.3. C value is what? 1.3 farads. So here what I told you, 1 by 3 is nothing but it is lesser than the 2. That is I told you. What is that? The effective capacitance values must be less than the least value of combination. Least value of combination. So children, so this is about the, simply we can find out the, when we have two only, we have to use form this one. CS is equals to C1 C2 by C1 plus C2. So children, this is about the series combination of capacitors and expression for the equivalent capacitance of that combination. So I hope you understand. If you can understand this video, like, share and comment the video. And my request is you must watch the video without skipping. Clear? So, and if you very interested about my videos, please subscribe my channel and share the videos also your friends. I hope you understand. So bye children, we will meet in the next video with some other interesting topic. Bye, take care.